Section 6.2 is about the trigonometric inverse functions. So here are our objectives for this lesson. We are going to find the exact values of inverse, sine, cosine, and tangent, as well as secant, cosecant, and cotangent. We're then going to use a calculator to calculate secant inverse. This is also called like arc secant, arc cosecant, arc cotangent, arc meaning inverse. Just so you know, in our calculator, which only has arc sine, arc cosine, and arc tangent buttons, and then we're going to write a trigonometric expression as an algebraic expression. So first things I want us to do is I want us to find the exact value of sine of arctangent of 4/3. Now remember with tangent, right, that if I have tan inverse of 4/3 is theta, this also means that tan of theta is 4/3. Now with tangent, right, because tangent takes on values between 0 and pi, we're only in quadrants. Theta must be in quadrant 1 or 2. These quadrants are very important. Now our tan of theta is positive, so we're going to be in quadrant 1. So I know that x squared plus y squared is r squared. Well, for tangent, that is y over x, right? So x is 3 and y is 4. So I have 3 squared plus 4 squared equals r squared. That means 9 plus 16 equals r squared. 25 equals r squared. So 5 is our r. Then if we want to find the sine of that, we're going to have sine of theta, right? This is our theta. Sine of theta, well, sine is going to be y over radius, which is 4/5. So that's how we're going to find the exact value of an expression involving an inverse and a trigonometric function. Let's work through another example. What if I want to find the cosine of arcsine of -4/3? So sine inverse of -4/5 is theta, because sine of theta equals -4/5. So remember that arcsine is only in quadrants 1 and 4, right? Remember, sine it can only be between negative pi over 2 and pi over 2. So we're in quadrants 1 and 4. We're on the right-hand side of our unit circle, right? We're over here. Well, because sine of theta is negative, we're going to be in quadrant 4. Let me switch to blue. It's a less angry color. So again, we're going to use this circle method. I know that x squared plus y squared equals r squared. Sine of theta is y over r. So I have y is 4 and r is 5. So I'm going to solve for x. X squared is x squared plus 4 squared equals 5 squared. So x squared equals 9, because this is 16 and 25. So x is 3. And our cosine in quadrant 4, which is where we are right now, is going to be positive. So I'm going to take the cosine of my theta, which I know is going to have an x value of 3 and an r of 5. So cosine of theta is 3/5. Let's take a look at another problem. I want to find the exact value of tangent of arc cosine of negative 1/3. So remember that cosine, arc cosine can only take on theta values between 0 and pi, right? We're in the top half of our unit circle. So we're in quadrants 1 and 2. So cosine, arc cosine of negative 1/3 is theta. So cosine of theta is negative 1/3, right? Remember that cosine of theta, because we don't know the circle's radius, that's going to be x over r. So I have x is 1 and r is 3. So I've got x squared plus y squared equals r squared. So 1 squared plus y squared equals 3 squared. 1 plus y squared is 9. Subtracting 1 gives us 8. I take the square root of both sides. I get y equals 2 square root of 2. So if I want to find the tangent of theta, I know that my y is going to be 2 square root of 2. And my r is going to be 3. But wait, what quadrant am I in? My cosine, my x value was negative. So I'm in quadrant 2. We're over here in quadrant 2. So that means my tangent's going to be negative. So my tangent is going to be negative 2 square root of 2 over our over x, which is 1. So that's just negative 2 square root of 2. So let's look at the definitions for the inverse of secant, inverse secant, inverse cosecant, and inverse cotangent. I'm going to start calling them arc secant, arc cosecant, arc cotangent. I think that'd make life a little bit easier. So if y equals arc secant of x, that means x is secant of y. X has to be greater than or equal to 1 if it's absolute value, so it goes from negative 1 to x to positive 1. That's what this means. And our secant, which is 1 over cosine, goes from 0 to pi, right? That makes sense. Arc cosecant, again, can take on x values between negative 1 and 1, but it is 1 over sine, which is 1 over y, so it's going to have the same range as arc sine, so it goes from negative pi over 2 to pi over 2. And with cotangent, again, it's going to have the same domain as arc tangent, but remember, tangent's restricted to quadrants 1 and 2, so our outputs, our thetas, are only going to be between 0 and pi. So let's use this information to find some exact values of arc secant, arc cosecant, and arc cotangent.